17 April USQAS test, and let's jump in. So 32 says, which data presented in the table would MacKinnon find most useful to his argument? So the way to solve this one to begin with is I wouldn't actually go to the table. I would go back to finding out what MacKinnon's argument is again. Now, even if we've done this question, or sorry, even if we've done this passage already and we remember what MacKinnon's point of view was, because a couple of the questions relied on that, I will still go back to where he's at, to where he's mentioned, and I will still sort of articulate again what are all the things that he finds that he uses in his argument. There's not too many things, and then I'll match them to the table to make sure I'm not missing anything, right? I'm not going to trust, I have a good memory, but I'm not going to trust my memory that much. So then what we'll do is we'll go back to where MacKinnon is mentioned, and MacKinnon starts, if we remember, starts up here in about line 8, this second paragraph here, and he goes down to the end of the third paragraph down here. So what I'm going to do is I'm just going to sort of note the things that MacKinnon makes, the comments that MacKinnon makes that are important to his argument, and I already have a sense of what this table measures, right? It measures distance, radius, mass, density. So anything that sort of relates to one of those questions or topics, something that seems plausible for the table to mention, I'm going to sort of underline those and include those and try to remember what those are. So diameter. So first thing we see is that Ceres is by far the largest object in the asteroid belt. Okay, that's pretty good. Largest object in the asteroid belt. He also points out that Ceres has a low density. That's pretty interesting. And he compares, he says that's a high proportion for an asteroid, but closely matches Pluto and other icy objects. He talks about dip in Ceres light spectrum, right, because of ammonium-rich clay. This could work, however, we notice that nothing about the surface composition, about ammonia-rich clay, about light spectrum is reflected here. So for that reason, we probably can only really look at low density, matching Pluto, and being the largest object in the asteroid belt. So for largest object, I'm going to look at radius, right? Radius is going to give us the size of it. And we notice there's only two things in the asteroid belt. We have Juno and we have Ceres. Everything else, I think, is not part of the asteroid belt. And when we look at radius, we see that, yeah, Ceres is much bigger than Juno, by far the largest object. So this could be something that we look at, right? Maybe that will help, right? Maybe that's a supporting quality. What about the low density? So we look at Ceres here. Ceres has 2.7, and we don't have much to compare it to as far as other asteroids except for maybe Juno, where the density is actually pretty similar. However, we can note that it is kind of similar to Pluto, right? 2.1 to 2.7. You know, there's a little bit of a difference there, but some of these are Earth is a lot more dense, Mars is a lot more dense, these other objects are a lot less dense. So I don't think we can exclude it yet. So we can just look at the answer choices now to help us determine. Maybe one of them will talk about the size, and maybe one of them will talk about the density. Whichever one that is could be our correct answer choice. Maybe we're missing something, but for now I think we're in a good position to start solving. So A says the average density of Pluto is similar to that of Ceres. Now we know that this would kind of confirm his argument because we already saw up here where he talked about the low density of Ceres closely matching Pluto. So that's a good thing for his argument. And 2.7, we already said, to 2.1 is maybe, it seems like it could work, right? Let me draw some arrows because I like that. All right, maybe this wasn't worth it. Yeah, it wasn't worth it, but I'm committed, so let's finish. Good. So 2.7 to 2.1, pretty similar in density. Then we could probably keep answer choice A for 32. B talks about Neptune being much farther from the sun than Ceres. We could go back and look at the distance to see if that's true in the table, but it's not going to matter because we already looked at everything that MacKinnon talks about in the passage and it doesn't end up being important. So B we can eliminate. C says the mass of Ceres is only slightly greater than that of Juno. Right, so maybe here, what I noticed some students got confused on this question is that they think they equate mass as in like the actual just volume of matter with the size, right? Because we remember up here that it says that Ceres is by far the largest object in the asteroid belt. So maybe the fact that it's greater, although slightly greater, sort of diminishing that claim a little bit. Whatever the case, he doesn't say anything about mass. He does talk about size. He doesn't say anything about mass. He talks about size and density. So C is not a good answer choice. D says Ceres is denser on average than either Neptune or Uranus. We're talking about Ceres having a low density is sort of his point, and he never really compares it to Neptune or Uranus. It doesn't really matter for his argument. So D can also be eliminated, which means that we have to end up with answer choice C for our correct answer for question 30.